So we're here today at LumenRadio with Carl, Product Manager and Modbus expert. We have this exciting box in front of us. So Carl, what are we going to do today?
Yeah, so today we figured out, let's show what's inside our Modbus and BACnet dev kits. So Rob said I'm a Modbus expert. I don't know about that, but I know a lot about Modbus and BACnet. And we work with building automation, OEMs and end users, and we want to help OEMs get going faster. So that's why we brought this dev kit to the world. And what it does is that it helps you as a product manager or engineer to get going with a proof of concept or a prototype, so you can prove to your sales team or your management team how wireless Modbus or a wireless BACnet solution would look like in your case. And yeah, today we're using the Modbus dev kit, but the BACnet dev kit looks exactly the same, but it has different firmware on it.
Fabulous. So go ahead and break this open.
Yeah, do so.
You can let me know what's inside.
Yeah. So if we show the audience here, so what you will see here is that in the middle you have two end user products, and basically you could actually only start with that directly. Just connect a controller and a device and get it going. The user manuals are also inside the boxes, and we have different videos on YouTube on how to get going with the simple 5-minute setup basically. But then the interesting part today is, of course, the other stuff in here. So in the kit, you would get an LumenRadio dev board. So I will go ahead and open this. Just remember, be careful with your ESD and make sure to have everything protected so you don't do anything strange there. And basically here, what you see in the dev board, it's an LumenRadio dev board where you could either have a Myra OEM module or an MLE module, or in this case, you have a W-Modbus module on board. It's powered through USB, and we have a detailed document description as well on the web page. But the idea here is because we were discussing, Rob, and I was saying like, yeah, it should take less than an hour for our product manager to get going with this. And then Rob and me discussed, let's show the 1-hour challenge, how to get going.
And of course, this can probably be done in less than an hour as well, if you really know what you're doing.
Yeah, of course, but you should get the box and you should open it. Then you have to tear down some plastic, make sure you have ESD protected stuff going. And of course, you need a controller and you need a couple of wires as well. So I will hopefully guide you what stuff it's not included in the box and what you also need in your office to get it going as well. But besides from the dev board, so like with a dev board, you don't have an RS-485 connection. So that's one of the things you actually have to develop, and you communicate with the module over either SPI or UART. But to do this 1-hour POC, we basically made it even easier. So the module will automatically start up as a node. So basically, if you take one of your end user devices, hook them up as a gateway, that one will then, or basically the module will find that gateway, and then you can just communicate over Modbus or BACnet to prove that it's actually working. So that's what we're going to do today. And to help the module there, so like instead of actually having all the pinouts and doing that to get SPI, UART, and RS-485 going, we developed a shield, which I will open up now and show. And the shield is a bit future-proof. So we added a couple of components that currently is not in use. That could be good to know. So for example, in our end user products, we have dip switches for both setting, which should be a node or a gateway, as well as the baud rate settings. And we also have example LEDs. Those are not currently in use, but could be enabled in future use. What we do have is the SPI pins, and we actually have UART pins now, but they are not marked on the Modbus board as well because it just got released basically. And basically what you need to do is just hook this up to the board and then connect RS-485 here. And then the dev board speaks wireless Modbus.
Easy as that.
As easy as that. And we didn't mention one more thing that is good to know, and that is that in the box, you don't only get the OEM dev board and the shield and the two end-use devices. You get, of course, also the USB cable to connect the dev board to the computer for power. But when your future down the road wants to actually build your own PCBA, we have 5 modules already ready for it. So you don't have to order that separately later on in the process, basically. And behind all of this, you also actually have 3 example antennas. So I just wanted to walk through. So you could actually theoretically, if the end user device and the dev board is just next to each other, it will theoretically actually join because its signal gets through, but that's not the intention. So basically, the module needs an external antenna, and there's a couple of options here you could do. So I was thinking we could walk through that.
Perfect.
So this is the antenna we use in our wall mount products, and it's called a Molex, and you just stick it on to any plastic surface or typically the encapsulation, and it's an IPEX connector that goes onto our board. The second option could be an external antenna, quite small footprint that you basically connect outside your device, and it connects directly to the Modbus module. The third option, which is quite popular in our lighting business for outdoor use, is to have an IPEX to TNC connector. And then you could have any external antenna on the market that speaks TNC then. So here in this example, you would be able to do like this and put it like this or like this. And this example antenna we have is a quite good antenna with good radiation patterns and so. And of course, we love to talk RF all the time, but that's not what we're here to do today, right, Rob?
Not today. No, exactly. This is solely Modbus / BACnet.
Exactly. So, but for fun, I'm connecting this anyway to my IPEX connector.
That just clicks in place.
Yeah, it's supposed to click, but the IPEX connector is really, really small. So this is typically done in production.
It's very small opening there.
Yep, it is.
Which is why it's a 1 hour challenge, not a half-hour challenge.
Exactly. So that's when you say it could take short time. Yeah, it could, but I prefer getting this done right. There we go.
Perfect.
All right, so yeah, we just got the antenna in place, and yeah, before we do the USB powering up, what we would like to do is actually have a gateway and make sure that this dev board can connect to a gateway. So I have prepared just like a chef on TV. So if we take, and of course the USB cable is included for the powering, and it's quite important, good to know that you have 2 different USB ports on the Myra dev board. And for the W-Modbus module, we use the mid one saying USB IMCU. So it's the one on the middle and not that one. And it has its correspondent dip switch inside below the shield here now, where you could check that you have the right dip switch session for powering the module. So I plug it in the computer, but not yet in the module. So what I need to do now is to do a gateway, and that's why you have the end user product with you. But as I said before, we have prepared a bit. So here I have prepared basically one of our wall mount units, and it goes with RS-485 to my computer, which will be the client, or sorry, the Modbus master, yeah, also called client. It's powered through 24 volts, so that you need to have on your own. We don't have a 24 volt adapter with us. Now I'm also wrecking the scene here. Excellent. Besides from that, we also have Modbus units as an example. So this is where your device come in, whatever device you have. So like if you have a BACnet device and you have our Wireless BACnet OEM dev kit, then you need to have a BACnet device, which already today speaks BACnet MSTP. If you have a Modbus device you want to make Wireless Modbus of, then you have a Modbus device. So here we just have an example device from S+S. And yeah, here it also requires 24 volts. So we actually use the same 24 volt power supply, but with a hidden cable like here. So, and then of course, this RS-485 is what we're going to connect to our dev board. So on the top of the Modbus shield, you have A, B, and ground. And here we only use A and B today, but if you need ground, then we have that. All right, so now you have the serial communication, or sorry, the Modbus communication between the Modbus device and our Modbus shield that goes to the Modbus board. Then we can move this maybe a bit aside. And you have the antenna. You don't yet powered up the module over USB. We will come to that. And then basically here, if we turn on the power here, our end user product will start up in node mode, so it will have sweeping blue pattern. So we need to set it to gateway commissioning mode. And basically we do that by flipping it to the mid state on the dip switch. And then it shifts to green, sweeping green instead of sweeping blue. Now the module should be ready to connect. So therefore we connect the power like this. And you could also confirm that the power is on with a couple of LEDs here on the board. And now it will start searching for a network. And if you have the opportunity and know how to do UART and SPI as a product manager, feel free to use the SPI or the UART interface to validate. But we will do a separate recording on that, more aimed towards the engineers that will actually do the SPI or UART implementation. Now we're doing the dummy version, which is basically no actual confirmation on the module, but we will actually from the gateway pull the Modbus device. That's what's the 1 hour challenge is about, getting things done really fast. So I have prepared a Python script that we will now run. So here you see that I have made a Modbus dev kit example, and it's basically just a standard Modbus open source library. And basically what it does, it's taking this Modbus sensor and looking at it. And today we are using address 2. So we need to check which address you have, of course. And then basically just call it. And here you see I've already tested before that we actually get response on address 2. And that was over wire, just to make sure it works. And talking about Modbus, you probably now wondering, but how do I set the baud rate? And basically how you do that is that with wireless, you don't have to have the same baud rate across the entire network. You can have different baud rates depending on which nodes you're using. But now remember, we don't have any SPI or UART interface on this dev board right now, so it's hard to set the baud rate with this device. Therefore, we will utilize the wireless communication to send baud rate over here. That means that the gateway's baud rate with the computer, which I've set to 38,400, will be the same as the device. And yeah, thankfully, I've already set the device to 38,400. Quite handy.
Yes, very handy.
So that's good to know that you need to have the same baud rates if you're going to let the gateway give its baud rate settings to the OEM module, basically. So here, I will just run my script. And basically, you already see, while I've been chit-chatting, the device actually have already wirelessly connected to the gateway. And how I will prove this now is because like you guys think maybe I cheat. So what I will do now is that I will actually lock the network as well, because that's the final stage. And what you will see is that the gateway is rebooting.
Yeah.
And during that time, I should not get any more responses. And I still have some responses coming in, but quite soon in the next phase here, I don't get any more response. And that's because the network is rebooting. And basically, it's trying to send out a request for response. And it will take, again, up to 2 minutes before the node again rejoins network. So let's see live how long time it takes to rejoin the network. But now we basically made the final step where we encrypt the network and locks it down so no one else can join the network. And after that, basically, we will be able to have a secure connection that is stable. And that's basically the last step to prove that you have done a proof of concept or a prototype with your specific Modbus device.
Fantastic. And what are we looking for? What sort of color lamps are we looking for?
That's really good question. Thanks for asking. So on the mid LED here, we see a green LED blinking. That's basically showing I'm trying to ask. When it gets replies, it will get a blue response back. And on the screen, we will see replies coming back. So basically, this is the no control prototype, which means, of course, you don't see anything on the module. If you would have UART or SPI, you would continuously scan for the state, basically, of the module. And on our end user product, if you're a node, then that one is blinking yellow, basically.
So still looking.
Yeah.
And this could take up to 2 minutes.
Exactly. So that is the awkward silence you actually have to wait for. But we saw the communication before, so it's always taking some time to rejoin the network, and this will happen with your products as well when it's on the market, that it takes some time to rejoin the network, basically.
But you're feeling confident?
Yeah, for sure. Now and there you go. Just when you asked me the question, it started asking again.
That's super magic. Excellent.
And here you can actually see now, if you're looking on the LEDs, it's just bursting messages instead of just sending one as. And that's what you're seeing, because I'm asking not only address 1, or rather registry 1, I'm asking 4 registries. And here you can actually see now that we're getting the temperature in here is 23.4 degrees. It's getting hot in here, so to say.
Yeah.
And both the first 2 are the same value, and then you have a couple of other values. So, for example, the 475, that's actually the percentage of full set point. So if I go all the way to the bottom on the set point, it's 0 on the third message here. While later on, it's still 0, but now in the next query, it will have 100, or I think it will say 1,000, because you divide by 1 extra. So that's basically how set points work.
Brilliant.
And now it should go back to roughly 50.
So this is now showing that the dev kit is connected. You've created the Wireless Modbus network, and it's
So basically, this would be the first step of your evaluation process when you want to make an Wireless Modbus OEM design, basically. And of course, you don't need the dev board at the first stage. You could just use 2 of the end user products. Basically, instead of having a dev board, you could use a wall mount or a DIN rail connecting directly to your existing product. But the second you have gone to your manager, got the approval to do a prototype, you want to start fiddling around with the UART and SPI interfaces and getting those things right. And then it's much more convenient to already have the shield, which we have here.
And there were also, I think we said at the start, there were an extra 4 or 5 modules
Exactly.
in the kit.
It's 5 more modules for the third step of the process, which basically is designing it in on the PCBA. So then you already have 5 of them, which you can start designing in.
Fabulous.
Yeah.
And I guess that just if anyone's interested, how can you get your hands on?
Yeah, so it's of course reaching out to our sales representatives at sales@lumenradio.com or visit us at one of the trade shows where you find us.
Fabulous. Well, that's great. Thanks for your time. We look forward to the future videos. So we're going to be looking at the other, was it the UART and the
SPI. Yeah, exactly.
Brilliant.
So we're going to record, or actually my engineers are going to record 2 videos. One of them is with the UART interface and one of them is with the SPI interface. How you get going with those to actually do it, not the silly way like I did now, but more structured engineer approach to it.
Excellent. Well, great. Thanks for your time today.
Thank you, Rob.
And thank you for watching.